The illness continues. Shaq has been ill since I've been better, and the last video I made, I was really struggling with my voice at the end, and after that, my voice just completely gave out for another week. So, sorry for the lack of videos. Anyway, here's a fun one. Well, my granny charger has failed again. This is the second time this has happened, and this is actually a revision that was supposed to sort of fix it, but I now see that it's basically impossible. There's a reason for that. So, so if we look here, we see a lot of black discoloration. There's clearly been a very slight explosion here, but the granny charger, it still powers up. All the microelectronics still work. It still attempts to switch the relays, and the relays still work. They look good. They haven't been melted. So what has actually happened here? Well, we can see here that this bulbous thing, that's not supposed to be there. And if we look between the wires, you can actually see, I guess it's easier to see from here, that there's another bit of strangely lifted PCB here. And what has actually happened is something I didn't quite take into account when doing my calculations on the board. The wires, they come in here, they go pretty much directly into the relays, and then there's a slightly longer bit of wire that goes to the connection points for the wires that go out to the actual connections to the car. And these slightly longer wires, they're really fat tracks, and the copper is it's standard 18 micrometer thick copper. It should be able to handle this current, but clearly it cannot. The copper has gotten hot, and specifically what happens is this is the second time my granny charger has failed, and it failed on startup. I guess I haven't actually measured this, but I'm pretty sure that the issue is inrush current. There's apparently quite a lot of capacitance on the charger in the car, and the inrush current far exceeds what these tracks can handle. Because you have to keep in mind that if this track is designed for 16 amps, a 25 amp inrush current, which is it's probably much larger than that, so a 1.5 times higher inrush current is going to cause 2.5 times as much heat buildup. And probably the inrush current is more like 35 or 40 amps, fairly standard for power supplies, especially on like a long wire, lots of inductance, probably a lot of current running through there. So while these relays are designed to withstand that kind of inrush current, they have a peak rating of I think 50 amps. Clearly this piece of wire isn't on the board, so this is not an acceptable way to go forward with this. And there are a couple of other issues with this board, some of which I've tried to alleviate, but I'm seeing that this is just no good. So the board is very thin, and I made it thin on purpose so it could flex a little bit inside the connector without affecting the function of the granny charger PCB. But unfortunately, like, these wires, they're directly soldered into the board, which of course is kind of a bad connection, but I wanted to keep everything as small as possible and keep this like a very universal design. This flexes the board like so much, like it flexes down like 30 degrees here. This is not, this didn't happen when I first built it in. This is clearly, there has been some heat during charging that has caused this to deform over time. There's a little bit of creep of the polymer in the PCB material. And secondly, these wires that run all the length of the board, I did heat shrink them to give them some extra insulation, some extra protection from the low voltage stuff here. But I mean, this is also a bad solution. I knew this was a bad solution. And this is one of those reasons why I'm not selling the granny charger yet, and why it has taken so long for me to give out granny charger dev kits to the 2 people who have asked for it. because I know that it's not really good design, and I was hoping I could get away with this, but here the heat shrink has peeled off of a little bit of wire, and this is just a huge red flag. This is after just half a year of use, so this is just not gonna last. This is a granny charger that will fail after a year in anybody's use case. So yeah, I'm redesigning this. Clearly, these wires. This is a bit of a wiring mess. This is just no good. The wires will have to be connectorized. There's just no other way to it. So I'll extend the board slightly on this side and use the Wago clamping connectors, I think, where you just stick in the wire and it's good. No solder connection necessary. You have no issues of the cable breaking on the point where the soldered end goes into the flexible end. And then I will probably need to either make this a very thick multi-layer board. I think I'm actually going to go for that. And wire the high voltage wire all the way through and have another set of connectors here, or I'll have to put a second board on the bottom of this. The downside is that I will not be able to populate the bottom side, and I'm using that for the capacitors now, but I might be able to fit it in. And then just have connectors in the front that go to very short wires into this connector. So that's going to be the next revision. And for everybody who's been waiting on the granny charger, it's going to take about a month before I have the next revision ready. In the meantime, I'm just going to bodge repair this one, use it for a bit more, and then eventually switch to the new one. So yeah, so far for this post-mortem on my granny charger. Well, I fixed it again. I just resoldered the connections, so that wasn't hard. Anyway, see you later.